A student set up a galvanic cell that has an electrode of silver immersed in a 0.1 molar silver nitrate solution and an electrode of chromium immersed in a 1.0 molar chromium chloride solution. Here are the electrode potentials, one for silver, one for chromium. The two electrodes are connected via a voltmeter. The student measures the voltage and discovers that it is 0. Identify the likely missing component of the cell and explain its importance for obtaining a non-zero voltage. B. The student adds the missing component and measures the voltage. Calculate the value of E naught cell for the complete cell. C. Write the balanced net ionic equation for the overall reaction that occurs as the cell operates. And 3 more parts. D. Calculate the delta G naught for the reaction. E. What would happen if the concentration of chromium solution is decreased? F. What would happen if we add a pinch of sodium chloride to the silver compartment? Part A. Student measures the voltage, finds it 0. What went wrong? Well, the likely missing component is a salt bridge. Because there is no salt bridge, the reaction cannot be sustained. That is because the neutrality of the compartments is not maintained. Without a sustained reaction, the voltmeter will not read a voltage. The student adds the salt bridge and measures the voltage. Calculate the value of E naught cell for the complete cell. First, determine which metal will be the anode and the cathode. Since silver has a greater electric potential, it will be used for the cathode. Then we use our equation here. E naught is E naught cathode minus E naught anode. So that's going to be 0.80 minus a minus 0.74 volts. And we get 1.54 volts. The two electrodes are connected via a voltmeter. Write the balanced net ionic equation for the overall reaction. From part B, the cathode will be silver, so it will provide the reduction half reaction, while the chromium provides the oxidation half reaction. Now we have to have the same amount of electrons on each side, so we need to multiply this first equation by 3. And you get 3 silver ion plus 3 electrons yields 3 silver. Now we add them. And let me just erase something here so you can see what we're adding. We're adding this reaction to this one. So the electrons cancel out on each side. And this is our final equation here. That's our net ionic equation. Calculate delta G naught for the reaction. Use this equation here. Delta G naught is minus NFE, and plug in the calculated E naught value. And we have 3 moles of electrons. So that's the value of N. Here's our Faraday constant. Here's the voltage we found, and we get minus 441,000 joules, or I think most of the time we do this, put it into kilojoules. Either answer is good. What would happen if the concentration of the chromium solution is decreased? Using the Nernst equation, decreasing the concentration of chromium ions, the log expression value will decrease. The cell will shift to produce more chromium ions. The increased oxidation reaction produces more electrons for the cell and causes the cell potential to increase. What would happen if we add a pinch of sodium chloride to the silver compartment? Here's our reaction. Adding sodium chloride to the silver compartment, the chloride ions will interact with silver ions to produce the insoluble silver chloride. As the concentration of silver ions decreases, the value of the log expression in the Nernst equation, that's over here, that's going to increase. That will decrease E due to the negative sign in front of the last term of the equation. So E will be less than E naught.